Hello everyone, welcome to Reactify Labs. Today I am going to talk about another design pattern which is Singleton Design Pattern. How do I write it? Let me write it. Mhm. Either it's Singleton Design Pattern or Singleton Pattern, both works. So, what is Singleton? Singleton means only one. Single, as the name suggests, there will be only one. But what? What will be one? One will be the instance of the class. Okay, so Singleton pattern is a creational design pattern which ensures that a class has only one instance and that class will have a global access point, like that instance will have a global access point. Okay, if it is not clear, let me try to explain it with more example. Okay, let's say there is a country. Let's say the country is USA. Okay, the country has a president. If you see, this president is a single instance. Okay, there can be only one president at any time. Let's say some party X won the election. Then some person named A becomes a president. After some years, some party Y wins the election. Then a person B becomes the president. Okay. See here, the party changes. The person in charge of being the president changes, but the post remains the same. It is the president. Okay. This post has been created. It has its own rules and regulations, rules, responsibilities, responsibilities, duties. These things are defined for a president. It's not defined for any person. Okay, these are defined for a president, so that whenever any person becomes a president, what they do is they are immediately subject to these rules, responsibilities and duties. We do not go and create new rules for them, right? It means whenever anybody becomes the president, the originally created instance, it must have been created many hundreds of years ago, that immediately applies to the person. Okay, this is the real life example. I i know it may not be relatable very much in terms of the computer science, so I will give you a different example. For example, let's say you are using something called Duolingo. Okay, or you are playing online games like, let's say, chess, online chess. So what happens in these are, like, they have a leaderboard. Okay, Duolingo has some XP points. Chess has some I don't know, but there are also some points in chess which describes your level. I think it starts at 1500 something and goes till the grandmaster level, which is, I believe, 2800 or something. I'm not sure, but it's like this. Best example, LeetCode. LeetCode also has points or ratings, rankings. Okay, so these are there. So LeetCode has, okay, I think LeetCode is the best relatable example for people like us, so I will take that forward. In LeetCode there are two types of points. One is depending on how many questions you have solved. Depending on how many questions you have solved. Okay, sorry. This gives you your LeetCode ranking, I believe. Yeah, it's ranking. And there is one more thing which is called rating. Rating you get for competitions, competitions also you get ratings and rankings. Okay, and there is one more thing called competitions, which has ratings and rankings. Okay, and if I am not wrong, this is these are two rankings. One is a global ranking, and one is a ranking specific to a contest. Contest specific. Okay, so if you see here, this thing, this is a singleton, because let's say tomorrow a user joins LeetCode. LeetCode does not go and create another leaderboard for that person. It just adds that person in the leaderboard. It takes the same instance which is already existing, which had started since there was 0 users or 1 user of LeetCode, and it's going on like that since then. Okay, so this is singleton. LeetCode once instantiated the leaderboard as singleton, and it keeps using it. It keeps appending users to it as soon as new users come. Similarly, in competitions, if you see, the people get ratings. Ratings does not have anything actually, because rating is specific to a person. Okay, but rating calculator might have an instance. That is only one instance. Next comes rankings, but rankings has two things. If you see global is unique to everybody. It just adds one more user when one more user starts appearing for competitions. So that global instance is also singleton instance. But this contest specific, is it singleton or is it not? It is also singleton, but it's a different kind of singleton. Don't worry, there are no varieties of singleton. It's just that it is contest specific. So each contest has its own leaderboard. Because let's say currently the contest is going on is contest 100. So LeetCode creates a leaderboard for this, and just once it will create a leaderboard once for all the participants. Okay, next, if there is another contest next week, context number 101, then LeetCode is not going to use the leaderboard of the previous one. So there it has to make sure that the singleton stays within the contest. Okay, so in this, the global scope is within the contest. The contest is global, the contest number. So contest number 100 has its own singleton leaderboard. Singleton leaderboard 1. Contest number 101 has its own singleton leaderboard, right? So these leaderboards are still singleton but contest specific. So don't tell me that I'm telling something wrong. It's not. I'm not telling wrong anything, but it's just that this contest specific leaderboard has multiple instances, even though they can be singleton. Not can be, they are singleton, but they are singleton within a specific contest, right? Global also does not mean everything is accessible throughout the universe, right? Global means we define what global is. Okay, I hope this helps. So okay, just to make it simple, I'll give you an example. When we write a program in main, okay, and we do something, and we define a variable outside main, okay, this variable a is now global. We call this variable a global, but this is global in in the context, yeah, in context of this project only, right? So we define what global is. So when we say something else is global, if you see this LeetCode, this ranking, global ranking, it means it is for this, the globe is the entire earth, but for this contest ranking, the globe is only that contest. Okay, then I hope this clears it. So that's it about contest. These things are mostly like singleton design pattern is mostly used in things like this leaderboard. um, if you are playing, let's say, a game of chess with your friend, then it only creates one instance of the chessboard. Online chess game has a single instance of leaderboard. So all of them have like its own instances. If you are playing a game of chess with your friend, like friend A and friend B are playing chess, then this is a singleton. The the chessboard is singleton. When I say it's global, because it's global in the context of this game itself. So I hope this clears it. This chessboard is singleton, still singleton, but in the context of this game itself. But leaderboard, it's singleton, leaderboard or chess points ranking, but whatever you say, it is singleton in a context of the entire earth. Okay, I'm repeating it many times so that it becomes clear with different examples. I'm trying to explain so that people don't get confused later. How and when can we use singleton? Anywhere you can use singleton as long as you define your globe properly and you make sure that only one instance of your class is created. Okay. And I hope this is clear. So now I will just show you how to write the code for this, because writing code is very easy part, but in singleton there is some trick here. Okay. Let me show you how. Let's say there is a class called leaderboard, because we know in object oriented programming everything is an object. So if we have a lead code will also have its own leaderboard class. Okay. What it does is it will have an object called, let's say, generally we tend to give it a name as instance. Okay, so it will be of type leaderboard and variable name is instance. Okay, and we have a function called, it has to be public, it has to be static, because you know um, wait a second, public static get instance. Sorry, public static leaderboard, because it will be of type leaderboard, right? Leaderboard and get instance. Why do we use getters and setters? So that we do not provide access to outside access to these variables. So make sure that this variable is private. Okay. Does making it private only work? No, because since this function is static, this has to be static. Otherwise, the compiler will give you an error. You cannot use a non-static variable in static context. And for this function, the context is this context. This is called context, right? Starting from this to this. So this is within the context of this function, this variable, sorry, this context is static, and you cannot use non-static variables in the static context. This is standard programming principle. Okay. Next is we will check if instance is null. Okay. If instance is null. If the instance is null, what we are going to do is we are going to create a new instance. Create new instance, or as you write in programming, instance equal to new, or sorry, yeah, instance equal to new leaderboard, and just return this instance. Return instance. So whatever happens here is that this will come, code flow will come, and it will try to check for this instance. If uh, like it will call the get instance, basically get instance function, what it will do, it will check if the instance is null. If the instance is null, only then it will create. Let's say the game of chess or lead code, let's say lead code just launched. What happens is, as soon as it gets launched, this get instance is called, because it's static variables are initialized at the beginning. What it does is it checks, okay, first user comes, it checks the get instance of leaderboard. The instance is null at the moment because there is nothing right now, right? So what it does, it goes and create the leaderboard. It checks the instance is null, it creates the leaderboard, means it initializes this instance, and this instance is no longer null because it's static, it has only one copy. Okay. Next, let's say second user comes, then the function will come here and say, okay, the instance is null or not. Okay, it sees that, okay, it's not null, it means first user has already initialized it, so it will just return it. Just to make sure, to clarify, this is not inside if it's from here to here, and it returns here, return instance, it's still inside this bracket. Okay. So yeah, the thing that I talked about, context, everything has a context. If statement has its context from here to here, right, within these brackets. This method has its context from here to here. Class has its context starting from here and going to where that bracket closes. That is context. If anybody did not know this, maybe you know now. Okay, so we have this. Is there any problem with this? I don't see any problem, right? Because the instance is created. It checks if it is null, then it goes like if it is null, it creates. It's not, if it's not null, it will not create. So it will be only first time it will be created. Rest it will just return. Okay, but no, things do not happen that simply in our software world. We know that there are multiple users, concurrency comes here. So let's say there are multiple threads which do it. Okay, let's say there are 100 threads, means 100 people together logged in, signed up for lead code. Okay, because you never know, it's a very big world, there are 8 billion people. It is possible that multiple people are doing some things at the same time. So 100 people together came. Okay, 100 threads. So thread 1 checked for null, and thread 1, let's say thread 1 came here. Okay, right, it's good. And the context switch happens. Context switch, now I'm saying in terms of operating system context switch. It means the next thread comes, let's say it's round robin method. So thread 2 comes, thread 2 also sees that okay, it's null, thread 2 enters. Thread 3 comes, enters. Thread 4, thread 5, it's a round robin method, so everybody will get chance, right? So everybody is entering, checking the null, and they are here now. Here now what happens is everybody will go and create their instance. So there will be 100 instances, 100 leaderboards at the moment, right? So why this is happening? It was supposed to have only one. It means we are not handling our concurrency properly, right? So how we are going to do that? I hope this is clear what the problem is. Problem is if there are multiple threads, multiple context switch can happen, and for each context switch, each instance, there is a risk of creating a new instance. Okay, if we do not handle the synchronization properly. Concept wise it's good, but synchronization handling is required in the singleton, because rarely any system is single threaded, right? Because we need to accommodate for scalability, so the systems are usually multi-threaded. So okay, what do we need to do now? We need to do some changes. Okay, I will keep it like this and I will explain it again. So I will create another function. It's the same function, I'm just writing it again so that we can easily compare what earlier it was and what's now. So now we have something called, again the same function, public static leaderboard get instance. Okay, now what I will do is we will again check if instance is null. Okay, so if the instance is null, what are we going to do? We are going to make sure after this step everything has to be in the synchronized order, means in the single threaded order, synchronized. And we will call synchronized on which class? Leaderboard class, leaderboard dot class. If you don't know about synchronized keyword, look for it, Google it to know better. Here I will just explain what it does. It does this is, let's say if there are multiple classes, okay, sorry, not like this, it's here. If there are multiple threads coming in, so one thread comes, thread T1 comes here, now thread T2, T3, just like the previous case, T4, T5. If multiple comes in, after this, whichever thread enters, let's say T1 enters here, okay, it goes back from here, it goes away from here, it enters here. So another thread, if you see, multiple threads were able to enter this if, but multiple threads will not be able to enter this synchronized context. Within this bracket, multiple threads will not be able to enter. Why? Because that's the job of synchronized. Synchronized will allow the other thread to come only when already entered thread exits it. Okay, when thread 1 does its job and exits, only then T2 will be allowed to enter it. Okay, so this is the job of the synchronized, so allowing serializable access. Okay, so this is what it does. So now we have controlled that. Now let's see what the problem will be. T1 comes here, okay, T2 comes here, T3 comes here, and T1 exits, T1 comes. Now what happens is, let's see, it checks. Okay, now what we do is we create a new instance, create new instance, and we return the instance, right? It should be good because it's synchronized. But the problem is, see, there are multiple threads which are waiting here. They do not know if the instance is null or not because they are not checking. Now T1 enters, T1 creates the instance, exits. If these were not here, then it would not have been any issue. If these were outside, that would be perfectly fine. But these are inside, so they have already checked the instance is null. They know that instance is null, but when they were inside only, then T1 created the instance. So now they do not know that instance is already created. So they will also come and create. Here, if there are only 3 threads, 3 will create the instance. If there were 100 instances will be created. So to handle this again, we will use one more checking here. If instance is null. Okay. If instance is null, only then create the instance and return the instance. So even if there are multiple threads, T1 comes, T1 creates it, T1 exits. Okay. So the instance is created. Now T2 is already inside it. T2 will come and check, oh, okay, the instance is null. So it will exit. T3 will come, it will check, oh, the instance is null, it will exit. So it will not go and create any more instances, right? Right. So this is the way the singleton is coded. Okay, this is how you create. There is one more catch here, I will show you. If we write our function instead of like this, why cannot we write it like this? Why do we need a first check? Why do we need first if check? We can do synchronized leaderboard class, and we will do if instance is null, create new instance and return instance, right? We can do this also. Then even if multiple threads come, they will all enter in serial order, right? T1 comes, it sees, okay, instance is null, it creates. Now T2 comes, it sees, okay, instance is created, it will just go away. T3, T4, this will also work, but it has performance issues. The performance issue is if there are, let's say, 1,000 threads, every thread will come and wait on this synchronized class, which is not a desired thing. Okay, even if first thread has created it, why will other threads wait for it, right? So this is what this check is doing. It does not want the thread to wait here. Instead, it will just let it know outside, yes, thread has been already, sorry, the instance has already been created, you can go away. So that will go away. So thread 1 has created something, thread 2, let's say thread 1 created, okay, after a few hours 1,000 threads come, so all thread will just check this if and go away. But in this case, thread 1 has created, but even if next time all 1,000 threads come together, all need to wait here, which is not right, because this operation has more wait time than this operation. So that's why this additional check is necessary, and we call it double checked locking. So this is called double checked locking, and it is used in singleton. Okay, I hope this clears the concepts about singleton. See, this is the difference: single check, double check, and locking. So double checked locking. Okay, I hope this clears the concept about singleton. I'll come very soon with next video on some other topic. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.